And of course, go through this practice test here. Okay, so let me show you all the solutions. Z-score is always the one you want, minus the mean, the one in the middle, over your standard deviation. So there, that Z-score was 1.67. That means that score, that IQ, was 1.67 standard deviations above the mean. Okay, part B here, now we're going to use that Z-score. We're going to find the percentage of our population that's above that value. This is a normal model problem, chapter 5. So we draw our picture. We wanted to be less than something, so we shaded below. Find that Z-score, we just found it. Normal CDF, smallest thing I shaded up to largest. And we get this big number, 95% of the population is below that. Okay, and then part C here, we wanted to know the percentage of the population between two values. Find both Z-scores, draw our picture, find our Z-scores, normal CDF, smallest to largest. So here we're making predictions about individuals in the population. There are no samples here. It's just a normal model problem. Okay, here we drew a histogram. This is what your histogram should have looked like, because we said use a bin width of 10. This is kind of an ugly distribution. It's almost uniform, really. I mean, it's kind of flat. So down here, describing it, there are a lot of ways. It's not clearly any one. I guess you could even almost argue it's uniform. It's almost flat. You could say it's unimodal. Here's our mode and skewed left. Or I guess you could argue it's bimodal. We got kind of a big group here and a big group here. Here's what your stem and leaf plot should have looked like. Okay, all these numbers we get from the calculator. So you just literally type all these into L1, go to one variable stats on the calculator. That will spit out most of these, not this. Range, you always got to find yourself. Same with interquartile range. Range is max minus min. IQR is Q3 minus Q1. Okay, our different sampling techniques. Remember, we had 5. Convenient sample is you stand in one spot and pick the first 40 people that walk by. You take a convenient sample. It's usually not a good sample. It's a very biased method, or can be very biased. Simple random sample, you put everybody's name in a hat and you randomly draw, or you have your computer randomly generate 50 names. Tends to be statistically the best kind of sampling. It just takes a lot more work. Cluster sampling is you put everyone in a group and you sample entire groups. And each group looks like the entire population. Stratified sampling, you put everybody in a group, but each group is homogeneous. They all look the same. The groups do not look like the population. You separate everybody out. And then you take a small subset from each group. And systematic sampling is you follow some kind of pattern. Every 5th person that walks by, everybody whose ID ends in 7. So here, that would be systematic. Every 3rd person in the room, you're following a pattern. Here, you're putting everybody in groups, but those groups share a common characteristic. Everybody with a red car is in one group. That group doesn't look like the whole population. And take a small sample from each. Here we put everybody in a group. And then we talk to entire groups. That's cluster. So I'm talking to 1/4 of all the statistics classes. Every 10th person, that's systematic. Everybody whose ID ends in 2, that would be systematic. Okay, here we're doing linear regression. Make sure on your calculator that you turn on diagnostic. I mentioned this last time, and look, it's still even there. That's funny. Go into catalog, second 0, catalog, go all the way down to diagnostic on. Should do this before you even start taking the final. Right there, on, hit enter twice. Now your calculator will spit out R and R squared. Otherwise, it wouldn't tell you this number. Okay, so our explanatory variable is our X value. We think it might explain our response variable Y. So would height influence shoe size, or would shoe size influence height? If one's going to explain the other, it makes more sense that your shoe size would depend on your height. So height would be our explanatory, shoe size would be response. So we would type all these numbers into L1, all these, the second row, into L2. Then we do button 8. I don't have all those typed in, but I can show you where you would go over to calculate, down to number 8. You hit enter, go through the whole process. That will spit out your line of regression, your correlation coefficient R, and R squared. So here we got R was 0.99. That's very strong positive. Here was our model. That's our slope. The interpretation there is each additional X makes Y go up or down by that amount. So this says for each additional inch in height, we'd expect the shoe size to go up by 0.298 sizes. For each additional X, Y increases by this. If that's a negative, it would be decreases. This is our Y coordinate of our Y intercept. That says the model predicts if your height is 0 inches, your shoe size is -9. Of course, that doesn't make any sense, but you can't have a height of 0 inches. So our Y intercept usually is nonsense, and that's okay. Okay, now we're making a prediction. So they gave me an X, a height. I just plug that in, get a value. So this model would predict somebody that's 45 inches tall would wear a 4. If somebody asked me for a residual is actual value from the table minus your predicted value. So we know an actual value for 65, it's size 10. If I wanted the residual, I would plug 65 in here, get an answer, take the actual 10 minus that predicted, that would be my residual. Okay, now we're into central limit theorem. This was chapter 17. Here we're dealing with proportions. So we find our standard deviation, square root of p hat, or square root of pq over n. There's our p. Here we were looking at the proportion of students that drive to school. So that's p. P is the proportion of students that drive to school, 0.45. Q is 1 minus p. So we get this standard deviation. We were asked for a z-score. Z-score is the one we're asked about minus the one in the middle. Central limit theorem says in the middle is p. So I get 0.45 minus 0.45, that's 0. What's it mean to be 0 standard deviations away from the mean? That means you're at the mean. That doesn't mean our final answer is 0. When we draw our picture, that means we want to know what's the probability of being above the mean. That's 50%. Okay, now we're doing a confidence interval for means. So especially on this confidence interval and hypothesis test problems, before you get started, I know I keep harping on this, but it's really important. Decide which one of the 8 different problems you could possibly be doing here. Is this means or proportions? Get in that universe first. This is a mean problem. I know that because it says mean. Interval or test? Well, it says confidence interval. So I know I'm doing mean, and I know I'm doing an interval. Now, how many groups do I have? I got 2. So this is a 2 sample interval. So like you could just go to your buttons here in your calculator and see who has that. They look at 4, 2 sample test. It's close, not quite right. That says test. I want an interval. Oh, what about button 6? Nope, that says prop. Definitely don't want that. What about button B? Let's even go in there. Let's look at button B. I don't have any X's or N's. I've got X bars and S's. That can't be right. Like you can almost kind of do this by process of elimination. Here's what we want. Button 0. Look, that's all the stuff. I mean, obviously those aren't the numbers, but that's all the stuff we're given. Sample means, sample standard deviations, and sample sizes. So here's our N, our X bar, and our S for group 2 and for group 1. So we define our variable, let mu be the mean words per minute. Notice I didn't mention the groups there. I type all that in the calculator and it would spit this out. Notice we got a negative. We got to be careful here. We're always predicting how much higher group 1 is than group 2 on average. What's it mean to be negative higher? It means lower. So we're 95% confident the mean or average words per minute for group 1, women, is between 2 words per minute lower up to 6 words higher than men. Okay, now somebody makes a prediction that women are 5, on average, 5 words more than men. 5's in the interval, it's possible. If they make a prediction outside the interval, you don't believe it. If it's in the interval, you never say you believe anything. Never accept. That would be accepting a null hypothesis. If somebody makes a claim, you never accept their claim. You either reject it or fail to reject it. So we would fail to reject that. We just say, yeah, it's possible. Okay, I mentioned this last time that back in the day, we used to do these problems by hand. You would not be required to find the standard error and like to do all this by hand. You would just type all this in the calculator. Like, hey, we can do it real quick. It'll only take 10 seconds. So here we want to, our ultimate goal is to find a 95% confidence interval for Valencia students that have taken this course. Successes have taken the course. So let P be the proportion of students that have taken the class. I'm doing a 1 prop interval. So that's button A. Remember, X is the number of successes in the sample. 25 people in my sample took the course. N is my sample size. There's my interval. So that's all you'll be required to do. You don't have to go through all this work here. You could if you wanted. So we get our interval. Notice I rounded right there, no big deal. So we're 95% confident between 11.9 and 24.9% of students have taken the class. Now, what if we want the margin of error? If we did it by hand, the margin of error was one of the intermediate steps. If we use the calculator, we got to go through extra work to find the margin of error. And that's high minus low over 2. Okay, question 9. Again, decide what kind of problem you're doing before you just start plugging numbers in the calculator. Now, everything we've done so far, like test 3 was all proportions, test 4 was all means. Now it's all mixed together. So here, they don't give me a standard deviation. They don't say the words mean or average. This is not a mean problem. It's a proportion problem. The fact that they're giving me percentages is a big indicator of that. So define our variable. Let P be the proportion of students that have watched Walking Dead or that do watch Walking Dead. We have 2 groups, men and women. Men had a higher success rate, so I call them group 1. Their success rate was 36% versus 27% for women. Here are my hypotheses. Remember, these are all P's now, not mu's. We would type all this in the calculator. This would be button, let's see, this is a 2-prop test. That would be button 6. So we would just type in our 4 numbers, make sure we have the right hypothesis, hit calculate. That spits out our p-value. We got a high p-value, 16%. That's a giant p-value. Fail to reject the null, so we do not have strong evidence that group 1 has a higher success rate than group 2, which is what this says. And finally, number 10 says the word hypothesis. So you shouldn't be doing an interval. I see the word standard deviation. I know I'm in a mean universe. It's going to be a mean problem. How many groups do I have? How many different standard deviations did they give me? Just 1. There's no way this is 2 groups. They didn't give me enough numbers. This is a 1 sample t-test. That's button 2 on the calculator, the t-test. You should keep a list. You should write that down in your notes somewhere. Remember, the final is open notes. Write down which button does what. That's t-test. Okay, so define our variable. Let mu be the mean GPA, or GPA, miles per gallon, that this fleet of cars gets. Here are our hypotheses. We thought our average was 35, but the sample says no, it's not. It's less than 35. We draw our picture. See, here's our sample average. Right in the middle is 35. Our sample says we're only getting 32. We always shade a tail. Notice I shaded to the left and I wrote below. We type this in the calculator. Let's actually type this one in because I want you to see that on the calculator. So t-test, this was 35, 32.05, 483, and 75. And we chose right there, less than. Hit calculate. Look at that p-value. It is not 6. You will never, ever have a p-value bigger than 1. You shouldn't even get a p-value bigger than a half. If you get a p-value bigger than 0.5, you've goofed. That's 6 times 10 to the negative 7th. That's incredibly small. So we reject the null and accept the alternative. We have very strong evidence that the mean is below 35. So they failed to meet their goal. Their goal was 35.